Good day. The topic is on trigonometric basic identities and formulas. Under this are identities and equalities, fundamental trigonometric identities, expressing trigonometric functions in terms of sine and cosine, and then proving trigonometric identities. For the first, we have identities and equalities. What is an identity equation? It is an equation which holds true for all specific values of the unknown quantity. Okay. So for the identity equation, so it means that if we're gonna make use of any value, okay, any value, it means that when we say any, whatever, okay, whatever value that we are going to substitute in the equation. So after simplifying, the left side will always be equal to the right side. So it means that all specific values, okay? Um, s- One example of the identity equation is the 1 plus tangent squared theta equals to secant squared theta. And then another one, so we have the 1 plus cotangent squared theta equals to cosecant squared theta. Okay, so how is it, why is it, or in what way is the 1 plus tangent squared theta equals to secant squared theta? So remember, whatever value that you use, you can still prove that the left side is equal to the right side. So let us have an example. So again, we have 1 plus tangent squared 1 plus tangent squared theta equals to secant squared theta. Okay, so for example, say if you want to use a value for theta, say 30, okay? So it means that you're going to substitute the 30 degrees on the left side and the right side. So with all the theta that you can see. Okay, so we have 1 plus tangent squared, okay, of 30 degrees equals to secant squared 30 degrees. Next. So you can just use your calculator for this, but then how are you going to input the trigonometric function with power? Okay. So in your calculator, the one plus rather tangent squared. Okay, the tangent squared. But then if you want to input 1 plus tangent squared 30 degrees, you may do it. But if you would like it step by step, so it is up to you. This one, the tangent squared 30 degrees, this is actually equivalent in your calculator, or you can input it this way. So it is tangent of 30 degrees. Okay, then you have to square it. That's it. So in your if you would like to add the one, so that is 1 plus, okay, open parenthesis, tangent. I think in your calcu, when you input tangent, automatic it has parenthesis already, so open. So you have to close it after inputting the angle. Then close it again, then the power, 2. Then the secant squared of 30 degrees, okay, so that one, so if you do not have the secant in your calculator, I think you have the sine, cosine, and then tangent. You just have to make use of the cosine. Okay, remember that the reciprocal of cosine is sine, vice versa. So the secant squared 30 degrees, this is also equivalent to 1 over cosine squared 30 degrees. Okay, so it means that in your calculator, so you have to input it, this one, okay? So for this one, so including the one, so we have here 1 over, then open. because you're going to square the whole cosine 30 degrees. So you have your cosine. And then again, your calculator, once you press the cosine, you already have there the open parenthesis. So you input the angle 30 degrees, you close it. That's it. Okay. So 1 plus tangent squared 30 degrees. So this is 4 over 3. And then 1 over the square of cosine 30, it is also 4 over 3. Okay, so this is one of the values in which we can say that 1 plus tangent squared theta is really equal to secant squared theta. Just remember that this equation, okay, is one of the identities in trigonometry. Okay, it is a trigonometric identity. So it means, since it is already a trigonometric, this is a trigonometric identity. So from the term itself, identity, this means that this is, well, whatever value you use for the theta, still you can what? You can show that both sides are equal. Okay, because this is one of the identities. Okay, let us have the next. So we have 1 plus cotangent squared theta equals to cosecant squared theta. Again, if you try to review your trigonometric identities, this is one of those. So let us just prove that this is an identity. So again, when we say an identity, whatever value you use, so still at the end, you can show that both sides are the same or are equal. Okay? So if, for example, you would like to use theta equals to pi over 4. Okay. So remember that if you're going to input theta, the value of theta in your calculator, which is in degree, so you have to be sure that your calculator is in degree mode. However, if the value of theta is in radian, so just like the pi over 4, which you can see on the screen, so it means that you have to situate that the mode of your calculator is in radian or rad, so that you can have or you can come up with the correct or the right result. Okay. So let us substitute now. So 1 plus cotangent squared. This is pi over 4. So that is our theta. And then equals to cosecant squared of pi over 4. Okay. So same as what we did with the example a while ago. So since we do have here the square of a trigonometric function, so in your calculator, you're just going to input the trigonometric function together with the angle, and then you have to what? You have to include the power. However, since we do have here cotangent, so just like the secant a while ago, we're gonna apply the reciprocal. Okay. So we have here cotangent squared of pi over 4. So in your calculator, so this means that we have 1 over the tangent squared of pi over 4. Okay, so that is what? We have here, we need to put on the denominator the square of tangent. So that is tangent pi over 4. Then you have to close it. Okay, so this is how you're going to input it in your calcu. And then the same with the cosecant, because cosecant is the reciprocal of sine. So this one in your calcu is what? So reciprocal of sine. So that is 1 over sine squared pi over 4. So that is 1 over the square of the trigonometric function sine. Okay, then open, we have pi over 4, then you have to close it. Okay, So that's how you're going to input it in your calcu. The 1 over sine pi over 4, and then you close it using the close parenthesis, and then you square it. Okay. So the answer on the left is, so we have 2 equals. On the right, we also have 2. So we can say that they are really equal. Okay. So again, though, this given is one of the trigonometric identities. So whatever value you use for the theta, still left is equal to the right. Okay, let us go back to the PowerPoint. And we have the what we call as conditional equation. It is an equation in which equality will only be true for some specific values. Okay, for some, not all. Because the identity equation is for all. This is some. So possible that when you substitute a value for the theta, there are instances that left side is equal to the right side. But then there are also instances that when you use a value, so possible the left won't be equal to the right. If that is the case, so it is considered to be a conditional equation. Okay, from the word itself, conditional. There are only values or specific values in which the equation will be what? Will be really equal. Okay, so example is sine theta equals to 0. Okay, so before I show the solution, or well, this is actually trial and error when we would like to check, or when we would like to use well, values to substitute to the theta. This is again trial and error. The same with the identity equation a while ago. It is trial and error. Okay? So but then of course in identity, whatever value you use, still it will be equal, okay, at the end. But then for conditional, so there are values in which left would be equal to the right, and then possible not. Then we have tangent theta equals to 2. Okay, so let us have the first example. Okay, so the first example is sine theta equals to 0. Okay, so what if, for example, so what if our theta is equal to 0 degree? Okay, 0 degree. Okay, so if the theta is in 0 degree, so substituting, we have sine of 0. Do you think this is really equal to 0? By the way, class, with the identity equation a while ago, if you would like to put question, okay, a question mark at the, well, on the solution, you may do it. And then just put a check if you found out that it is really equal. Okay, for the conditional, so you can put a check if the two sides are equal. Then you can just put a slash if um, the two sides are not equal. Okay, so sine 0, so we have 0. Okay, so right side is 0. Do you think they are equal? Of course, yes. Okay, so another example. If theta is, say, 60 degrees. Okay, so substituting, so we have sine of 60 degrees. Do you think this is equal to 0? So with your calcu, the sine 60 degrees is equivalent to the square root of 3 over 2. Okay, then the right side is 0. So is the square root of 3 over 2 equal to 0? Of course not. Okay, so what does this mean? That when theta is 0°, so sine of theta is equal to 0. When theta is 60 degrees, so sine theta is not equal to 0. Okay, another one. So if theta, let us have region, 3 pi over 2. Okay, remember, since you can see here, well, the angle doesn't have the small circle, okay? And, well, it is very obvious that this is region. So you have to change the mode of your calculator into rad or region. Okay, so we have sine of 3 pi over 2. Do you think this is equal to 0? Okay, so sine of 3 pi over 2 with your calculator is -1. Then the right side is 0. So it is very obvious this is not equal. Okay, another example. So if theta is equal to -pi, okay? If theta is equal to -pi, so we have sine of -pi. Do you think this is equal to 0? So the sine of -pi is 0. Okay? So is it equal to the right? Yes. So this is an example of conditional equation. So as what you can see in our examples, there are values just like 0° and -pi in which the equation is true. And then there are also values in which the equation is really what? The equation is, well, or the given, rather the given is not equal, does not have equal sides. The left side and the right side are not the same. Okay, so let us have the next example. So the other one is tangent of theta equals to 2. Okay, so for example, if theta equals to pi over 2, so if you would like to substitute this, so the tangent of pi over 2, do you think this is really equal to 2? So I'll just correct this. Okay. So the tangent of pi over 2 in your calcu, it is math error. So if it is math error, it means that this is undefined. Okay. So of course, if it is error, it is not 2. So another example, if theta equals to -100°. So substituting, so we have tangent of -100°. Is it equal to 2? So we have tangent of -100°. So if you have your calcu, so be sure, since our first example is in region, so since the second is in degree, so you have to change the mode of your calculator into degree. So that is tangent of -100. The answer is 5.67. So 5.67. Is it equal to 2? Of course not. Okay. So this is conditional. If you would like to find the value of theta in which you can actually, well, you can actually determine the specific value to, well, the specific value of the theta, you can apply the inverse. Okay. So if you would like to apply the inverse so that you would know what is the value of theta, so I will clear the screen. So tangent of theta equals to 2. Because since this is conditional, by the way, in our first example, we identified what are the values of theta in which, um, well, um, the sign, okay, the sign of theta equals to 0. And we were able to solve or to come up with the values of 0, the negative pi. Okay, actually there are a lot more. So for this, so you can use inverse because in our two examples a while ago, both are not equal. So let us determine. So what can be the value of the theta? So if you can remember what we did in our first module on angle, so if you would like to solve for the angle, you make use of the inverse. So solving for the theta, so we have what? So the tangent, you have to write it to the on the right side, so it becomes arc tangent. Then you have here the 2. So with your calculator, if your calculator is in degree mode, so you press the shift. Well, it will depend on your calcu. If the combination of keys is shift, then tangent, then that's it. If you have other key combinations on your calculator, so you have to discover it. I would suggest that you use the browser. You just input the model of your calcu so that you would know the combination of keys. Because we do have different calculators. Okay, different models, different brands. So that is arc tangent of 2. So in degree, it is 63.43 degrees. Okay, in degrees. So if you try to tangent of 63.43 degrees, the answer is 1.9995. So it is almost 2. If you would like to have an answer in region, so you change the mode of your calculator into rad, then you input again the arc tangent, so that is shift tangent, and then 2. The answer is, so this one is in degree. We also have an answer in region, depending on the mode of your calculator. So theta is 1.107. So that is 1.11. So let us check. So tangent of 1.11. So that is 2.01. Okay. So if you would like to do the checking, so checking. So that is tangent of 63.43 degrees. That is 1.9995. This is somehow close to 2. If you would like to use the region, so 1.11, the answer is 2.01. Okay, so checking. This is for degree, then this is for region. I would suggest that if ever you found out that the equation is conditional, you have to solve for that theta by, by applying inverse. Okay. So going back to the PowerPoint, the fundamental trigonometric identities. Okay. By the way, class, the content of this PowerPoint is from the handout that I shared. Okay, it is uploaded in the references, rather in the resources in the LMS as a reference. So if you try to open that handout for this subject, so you can actually see lectures in our PowerPoint which are actually from that handout. Although there are examples, just like in the first module, there are some examples that are from that handout and then probably not from that handout. Okay. So for this topic, this is from the handout. So you can also try to check the handout. Fundamental trigonometric identities. So we have the quotient identities. You already know this. This is just a review, okay? So the tangent theta is equivalent to sine theta over cosine theta. And then since tangent theta's reciprocal is cotangent, so cotangent theta is equal to cosine theta over sine theta. I would suggest that you memorize this. Okay. Then product identities. Since we do have the quotient identities a while ago, so you're just going to multiply the denominator of the denominator on the right side with the what? With the left side. So we have tangent theta times cosine theta equals to sine theta. This is from the quotient identities a while ago. And then, again, multiplying the denominator of the right side to the left side. So we have cotangent theta times sine theta equals to cosine theta. Then we have reciprocal identities. So sine theta equals to 1 over cosecant theta. And if sine theta is equal to 1 over cosecant theta, therefore cosecant theta equals to 1 over sine theta. Cosine theta equals to 1 over secant theta. Then secant theta equals to 1 over cosine theta. And then lastly, for the reciprocal, tangent theta equals to 1 over cotangent theta. And also, cotangent theta equals to 1 over tangent theta. We have the Pythagorean identities. So for the Pythagorean, the square of the sum of sine theta and cosine theta is equal to 1. The 1 plus tangent squared theta equals to secant squared theta. This is one of the examples a while ago under the identity equation. It is a Pythagorean identity. And also the second example, which is 1 plus cotangent squared theta equals to cosecant squared theta under the identity equation a while ago, is a Pythagorean identity. So that is what I was telling you a while ago, that these two are considered to be trigonometric identities. So they are really identities. You're just going to prove that the left side is equal to the right side by making use of any value, whether the theta is in degree or in radian. Then we have the even and odd identities. So we have here 6. So if you try to, if you try to check, so all the angles, actually here, we made use of u for the angle. But if you would like to use theta, you can still do it. So you would notice that the angle on the left all have negative signs. Then on the right side, so we have what? So we do have the negative of the trigonometric function. We do have the positive of the trigonometric function. So try to notice that if you have the negative angle of a trigonometric function, the answer would be positive of the trigonometric function only for cosine and secant. Okay? Only for cosine and secant. And then the rest, the result or the answer would be negative of the trigonometric function. So this, you can see this cosine and then secant. The rest are negative trigonometric functions. Okay. Then, so let us have, for example, so let us have, for example, so sine negative u So sine of the negative u, remember, if you would like to use u or theta, you may do so. So equals to the negative of the trigonometric function. And then the other one, we have cosine of negative angle equals to positive of the trigonometric function. Okay. So example, if we have, if theta equals to say, let us have 45 degrees. Okay. For sine. So we have sine of negative 45 degrees. So do you think this is equal to negative of sine 45 degrees? Okay. So you can use your calculator. Be sure that you can change the mode into degree. So degree mode. So we have sine of negative 45 degrees. So the answer is negative square root of 2 over 2. Okay. Then on the right side, we have negative of sine 45. So you have to input in your calculus sine of 45. Sine of 45 is square root of 2 over 2. Remember that the negative here is actually before the trigonometric function. So we're just going to copy it. And then in your calculator, you have to input sine 45 degrees. So if you would like to, well, if you would notice that the left side is really equal to the right side. So another example, what if we try the cosine? So if you would like to try the cosine, so if, for example, okay, I would like to correct, just to correct the first. So we made use here of the u. So let us use u here. U. So on the cosine, so say we have u equals to, for example, negative um, 4 pi over 9. Let us try this. Okay. So substituting, we have cosine of negative 4 pi over 9. Do you think this is equal to the cosine of 4 negative, wait, negative, so we have here negative, that's it. So cosine of negative of u, since u is negative 4 pi over 9. So we have here two negatives here. Okay. Then on the right side, we have cosine negative 4 pi over 9. That's it. So cosine negative of negative 4 pi over 9 equals, is it equal to cosine of negative 4 pi over 9? Okay, so in your calculator, so be sure that you change the mode into region. So we have cosine of negative, okay, and then negative again, 4 pi over 9. You use two close parentheses. So the answer is 0.17. So 0.17. Okay. Then on the right side, we have cosine negative 4 pi over 9. So still the answer is 0.17. Therefore, the two sides are equal. Okay. So this is just to show you that the even and odd identities, making use of the values for the angle, well, we were able to show that, well, the identities are really what? They do have equal um, left side and right side. Okay, so you can do the same with the tangent and then the reciprocals. So you can use any values and then whether degree or region. So just be sure that when you input in your calcu, you have to double check what is the mode. Okay, next, expressing trigonometric functions in terms of sine and cosine. So example, express tangent theta in terms of cosine theta only. Okay. So in this example, so if we would like to if we would like to express tangent theta in terms of cosine theta only, this means that we need to think of identity that we can use to substitute for the tangent theta. Your aim first is to write the given trigonometric function in terms of sine and cosine. And then later, find a way how you can write sine in terms of cosine. So that from the tangent, you only have cosine at the end. By the way, if ever that, when we say cosine theta only, it is the only trigonometric function that can be seen on the answer. But then, if you have, for example, the cosine theta, then you do have a fraction, a radical, it is okay. As long as you do not have any other trigonometric functions at the, at the final answer. Okay. So if we would like to, to show tangent theta. Okay, so tangent theta in terms of cosine only. So in solving this, so remember, by making use of the identities, so we have the quotient identity. Quotient identity of tangent theta equals to sine theta over cosine theta. Okay. Um, when you do have a given like this in which it is not an equation, it is just an expression. So in order for you to show your solution, it should be vertical. Okay, it should be vertical. So I'll just write it on the black screen. So again, so tangent theta, we have to show this in cosine only. So by quotient identities, so we know that the tangent theta, okay, tangent theta is equal to sine theta over cosine theta. Remember, your first the first thing that you need to show to do, okay, you need to show that the trigonometric function can be written in terms of sine and cosine only. Then at the end, find a way how you can write sine in terms of cosine. That's it. So tangent is equal to sine over cosine. That's it. So sine theta over cosine theta. And then, what's next? So we have to find a way how we can write sine theta in terms of cosine theta only. So remember that in the Pythagorean identities, so we have their, we have their sine theta plus cosine squared theta equals to 1. Okay, so why is it that you're gonna make use of this identity? It is because you have here sine and cosine only, and no other trigonometric identities can be seen. Okay, so if we would like to write or to come up with with something we can substitute for the sine theta. So we need to derive this. Okay, so in deriving, so we have, we need to write the sine squared theta on the left side only. And then on the right side, we have 1. You have to transpose cosine squared theta on the other side. So it will become negative cosine squared theta. Okay, so remember, you need sine theta only. So you can extract the square root. So extracting the square root, So we have sine theta equals to the square root of 1 minus cosine squared theta. And that's it. So we can so I'll just erase this. Okay, so we can make use of this one. Okay, so sine theta equals to the square root of 1 minus cosine squared theta. Then over cosine theta. Okay, so this is the answer. Remember, your task is to express tangent theta in terms of cosine theta only. And in the final answer, no other trigonometric functions should be should be written other than the cosine theta. So um it is okay if you do have radical, if you have fraction, if you have exponent, that's it. Or if you have power. And then going back to the PowerPoint. So example number 2, express sine theta plus tangent theta over secant theta plus 1 in terms of sine theta only. So this time, only sine theta should be seen in the final answer. But then, same with example number 1, the first thing that you need to do is to write all trigonometric functions in terms of sine, cosine. Okay. We can have sine theta or cosine theta or both, depending on the identity that you are going to use. Okay, so let us solve for the second. So we have sine theta plus tangent theta over secant secant theta plus 1. Okay, so again we have sine theta plus tangent theta over secant theta plus 1. Okay, so the first thing that you need to do, you have to write all trigonometric functions in terms of sine or cosine or both. So on the numerator, we have here sine theta. So it is already okay. And then tangent theta. So remember that tangent theta, we have here the quotient identity. So tangent theta equals to sine theta over cosine theta. So it means that tangent theta can be written as sine theta over cosine theta. So we're able to write it in terms of sine and cosine. And then the secant theta, this is equivalent to what? So secant theta, so let us identify one identity in which we can have sine or cosine or both. So we can make use of the reciprocal. So secant theta is equal to 1 over cosine of theta. So let us substitute it here. So we have 1 over cosine theta. Then just copy the rest. So we have the plus 1. That's it. And then remember that we only need sine. Okay, we only need sine in the final answer. So we have to get rid of the cosine here. Okay, how? By substituting by substituting something in terms of sine only. So in terms of sine only, so this cosine can be replaced. So we can use here the sine squared theta plus cosine squared theta equals to 1. Because this is the only identity in which we do have sine and cosine. So in substituting, you have to take note that the two functions are present. Either either the function is what we need or the function is which needs to be replaced. Okay? So since we need to replace or we need to substitute something for cosine, so let us write the cosine on the left side. So same as what we did in the example a while ago. So cosine squared theta equals to 1. And then transpose sine squared theta to the other side. So it will become negative or minus sine squared theta. That's it. And since we need cosine only, so we have cosine theta. Um, Cosine squared theta equals to 1 minus sine squared theta. So we can what? Extract the square root. So we have cosine theta equals to the square root of 1 minus sine squared theta. So we can already substitute it here. So we have equals sine theta plus sine theta over. So we have 1 minus sine squared theta. That's it. Then on the denominator, we have 1 over, so cosine of theta can be replaced by 1, or rather, oh yeah, by 1 minus sine squared theta. Then copy the rest. So that is plus 1. That's it. And then the next thing that you need to do is to simplify this. Okay? So in simplifying it, so I'll just rewrite. So the last part of the solution was sine theta plus sine theta over square root of 1 minus sine squared theta. And then all over 1 over square root of 1 minus sine squared theta plus 1. That's it. So we have to simplify this. So the first thing that you need to, you need to solve or simplify first is the numerator, then denominator, or you can do it, you can simplify both the numerator and denominator at the same time. So for the numerator, so let us apply the LCD so we can add this to since the second is fraction. So the least common denominator of this is the square root of 1 minus sine squared theta. That is the LCD. So sine theta, we have your sine theta times the square root of 1 minus sine squared theta plus we have sine theta. Again, we applied here the LCD. Next, on the denominator, we're going to apply also the LCD because we do have a fraction and then we're going to add it with, with this one. Okay, this one. So the LCD of this is the square root of 1 minus sine squared theta. And then we have here 1 plus. So 1. So please review your LCD. Okay, review your LCD, review your algebra. Okay. So denominator times 1 is the square root of 1 minus sine squared theta. And then, if you would like to cancel the denominators, because we do have the same denominators here, you can cancel it already, having the same denominators. But then if you find it difficult, so you just, you just write this in terms of, having the operation multiplication. So just copy the numerator. So we have your sine theta times the square root of 1 minus sine squared of theta plus sine theta all over square root of 1 minus sine squared of theta. And then again, the division here would become multiplication. So we have the denominator a while ago. So since it will become multiplication, so we're going to write the denominator as numerator, then vice versa. So we have the denominator of the square root of 1 minus sine squared of theta. And then numerator will become denominator this time. So we have 1 plus square root of 1 minus sine squared theta. Again, you have to review your algebra. Okay? So now we can already cancel. So we have the square root of 1 minus sine squared of theta on the denominator and on the numerator. And then just multiply. So we have, so I'll just clear the screen and then rewrite. So we have sine theta square root of 1 minus sine squared of theta plus sine theta, and then the denominator this time would be 1 plus the square root of 1 minus sine squared theta. Okay, so you have again to simplify this. So you would notice that we have denominator 1 plus square root of 1 minus sine squared theta. Numerator, so you can also simplify the numerator in a way that possible you can factor this. Okay. So in factoring the numerator, you would notice you have sine on the first term and then sine also on the second. So by factoring, so sine theta square root of 1 minus sine squared theta divided by sine theta. So we have the square root of 1 minus sine squared of theta plus. So sine theta divided by sine theta, we have 1. So you can rewrite the numerator as sine theta times 2, 1 plus square root of 1 minus sine squared of theta. Okay, then denominator is 1 plus square root of 1 minus sine squared of theta. So this time you can already cancel. So the final answer here is sine of theta. By the way, the solution in the handout may be different from the solution. Okay, so remember that in trigonometric identities, formulas, and proving or in expressing the trigonometric function in terms of another trigonometric functions, since we are considering the identities. So possible that we can have several steps. We can have several solutions. So this is actually one of the solution. You also have another solution in the handout. If you would like to come up with another solution, you may do so as long as your solution is correct. Okay? Next, let us go back to the PowerPoint. So now let us have the proving trigonometric identities. In proving trigonometric identity, so this time we have an equation. So this is different from the third topic, okay, in which we were just given one expression. So we're just going to write it in terms of cosine or sine, depending on what is specified in the direction. So if you are given an expression, you have to solve it vertically. Okay, you have to solve it vertically. If we have proving like this one, you also have to solve it vertically. Okay, and you have to ensure that all the equal signs are what? Actually, it is it is arranged in a way that your equal sign is what? Is on the same line with the first equal sign, so on and so forth. Okay, so let us prove cotangent theta over cosecant theta, is it really equal to cosine theta? So that is proving. You have to show that the left side is equal to the right side. So in the handout, we also we have the solution for this. It is actually step by step. in proving, you can do the left hand or the right hand. So if you would like to simplify or to show that the left side is equal to the right side, or you would like to show that the right side is equal to the left side, or another option, if you would like to, well, if you would like to make use of identities on both left and right, and then at the end we're gonna simplify, then you can come up with the same, okay, the same um you can come up with the same left side and then right side. So for this, again, let me write the given. So in proving, so cotangent theta over, so cotangent theta over cosecant theta, is it equal to cosine theta? Okay. Actually, they are already equal. What you need to do is just to prove. And in proving this is trial and error. So there are instances that your solution can be short. Then there are also instances that you can have long solution. It will depend on you. Okay. So if you would like to, if we would like to show the left side equal to the right side, because remember that in the third topic, so what we did is, well, on the first step, we have to write the trigonometric functions in terms of sine, cosine, sine or cosine or both. Sometimes it is easier to prove by by simplifying complicated terms. Okay, rather than making complicated the simple term. But then it is up to you. Okay, it is up to you. So let us determine which one is complicated. Is it the left side or the right side? Of course, it is the left side. So after identifying which is the complicated side, you have to write it. So complicated side, you have to identify it. Then the next, write it in terms of sine theta or cosine theta or both. Okay, this is using identities. So the cotangent theta, the cotangent theta, this is equal to, by using the quotient identity, this is equal to cosine of theta over sine theta. So again, your goal is to write it in terms of sine or cosine or both. Sine theta. Okay. So we have your cosine theta over sine theta. And then the cosecant theta, so using reciprocal. Okay, so that is the reason why you have to memorize the identities. So cosecant theta is equivalent to 1 over sine theta. So 1 over sine theta. And then remember what I told you. You have to show the solution vertically. So this, the equal sign should be on the same line. Okay, they should be parallel. And then we have cosine theta on the right. Okay, so it is obvious that we can already cancel the sine theta because we have fraction on the numerator, fraction on the denominator, and you can see that both have the same denominators. So we can easily cancel this. Okay, so we have cosine theta over 1. Is it equal to cosine theta? So of course, they are equal. That's it. Okay, that is proving. If you would like to apply multiplication here, so cosine theta over sine theta times sine theta over 1 and then just cancel, you can do it. So you can have, so in this side, another solution for this, you can have here cosine theta over sine theta. And then since we do have here division, this can become multiplication. And then reciprocal of this, we have sine theta over 1. Then that's the time that you can cancel. Okay, next. So going back to the PowerPoint, so we have another example. Again, in the handout, we have, we have solution for this. So you can see that the solutions can be different, but then having the same answer and knowing that the solutions are correct. Okay. So if you have another solution for this, you may do so. Next example. So we have cotangent theta plus tangent theta equals to secant theta, cosecant theta. Okay, so let us write it. So the given is cotangent theta plus tangent theta equals to secant theta, cosecant theta. Again, the first thing that you need to do is to determine which one is complicated. Okay. The second thing that you need to do is to write it in terms of sine theta or cosine theta or both by using identities. That is what you need to do. Okay. So in identifying which side is complicated, okay, just to let you know, complicated sides, well, you have to identify which has the addition or subtraction. Okay, addition or subtraction for the complicated side. So we do have here the left side. Okay, so the left side is complicated. So since the left side is complicated, so we're just going to copy the right side as secant theta, cosecant theta. And then you have to write the left side in terms of sine or cosine or both. So cosine, the cotangent theta, again, cotangent theta is, by using the reciprocal is tangent, quotient. Use the quotient. So cotangent theta is, you can use quotient. Okay. Or if you do not like to write this in terms of sine, cosine, so since there's a tangent here, you can use Pythagorean. Okay. Or, well, whatever identity you can use. Um, so let us just follow this. Okay, those that I write on the right side. So writing this in terms of sine, cosine, so we have cosine theta over sine theta. This is quotient, identity. Okay, plus the tangent also has equivalent in terms of sine and cosine. So quotient also. So quotient is sine theta over cosine of theta. That's it. Then you can just write the right side properly. It should be aligned. Okay. So let's align this with the left side. So equals secant theta, cosecant theta. And then on the left side, we can apply here the LCD. Okay, LCD. Let us apply here the LCD. So the least common denominator of this is, of course, the product. So just multiply. So sine theta, cosine theta. Sine theta, cosine theta. And then denominator, okay, times the numerator divided by the denominator. So we have what? So we have here cosine square theta. So sine theta, cosine theta times cosine theta. So we have sine theta, cosine square theta divided by sine theta. So the answer here is cosine squared theta. Same with the other term here. So the LCD times the numerator divided by the denominator. So we have here sine squared theta. Next, so you have to, well, you can see that the cosine squared theta plus sine squared theta seems, well, familiar. Okay, so you can apply here the Pythagorean. Okay, remember that in the Pythagorean, sine squared theta plus cos squared theta equals to 1. So it means that we can write the numerator as 1. Okay, so writing this, so that is 1 over the sine theta cos theta equals to secant theta cosecant theta. Okay, next. So the left side, you can actually split this because this is multiplication. So I will, well, I will clear the screen. So with 1 over sine theta cosine theta equals to secant theta cosecant theta. Again, you can split this because this is multiplication. So in splitting this, we have 1 over sine theta times 1 over cosine theta equals to secant theta cosecant theta. Then just, well, use identities on the left side. So 1 over cosine theta, so we have the reciprocal cosecant theta times 1 over cosine theta is equivalent to secant theta. So remember, the right side has the operation multiplication. So the left side, you just rearrange this. So cosecant theta times secant theta is equal to cosecant theta, cosecant theta, secant theta. So just rearrange. So this can also be written as secant theta, cosecant theta equals to secant theta, cosecant theta. Okay, that's it. Again, if you have any other solution, so you can do it. Okay. Next, another solution for this. So again, the given is cotangent theta plus tangent theta. Remember what I told you a while ago? You can use Pythagorean. Um, okay. You can use Pythagorean here. Okay, but before you use the Pythagorean, you would notice that the cotangent theta and tangent theta, they are somehow related. Okay, so the cotangent theta can be written as 1 over tangent theta because what? Because it is the reciprocal. Then just copy the rest. Okay, next. So here you can already apply the LCD. Okay. So the LCD of this, so of course you have tangent theta over 1. Okay, invisible 1. So multiplying tangent theta times 1, we have the LCD of tangent theta. And then tangent theta times 1, so tangent theta, divided by tangent theta, we have 1. Plus tangent theta times tangent theta, we have tangent squared theta, divided by the invisible denominator here of 1. So we have here tangent squared theta. Okay, next. So the 1 plus tangent squared theta, so if you try to remember the identities, so we can already substitute. So what is that identity under the Pythagorean? So we have, so this one, so 1 plus tangent squared theta, if you can remember, is also equivalent to secant squared theta. So we can write here the secant squared theta, okay? Then denominator of tangent theta, copy the right side. Remember that the equal sign should be aligned. with each other. Okay, so next, so I will be clearing the screen. So after applying Pythagorean identity, so we have there the secant squared theta over tangent theta. Again, we have on the right side secant theta, cosecant theta. Okay, this time, you can already write this in terms of sine and cosine. Okay, this too. You write this in terms of sine and cosine. So secant squared theta, so in terms of sine and cosine, so secant squared, use the reciprocal. So that is 1 over cosine squared of theta. Okay. Remember that the secant squared of theta, this is also equivalent to secant theta raised to 2. This is also equivalent to the square of, since secant theta has a reciprocal 1 over cosine theta, so you can actually simplify this. So the square can be distributed on the numerator and denominator. So we have 1 squared, okay, over cosine theta raised to 2. 1 squared is 1 over cosine theta raised to 2 is cosine squared theta. That's it. Okay. And then the tangent, so you just use the quotient identity. So tangent theta is equal to sine theta over cosine of theta. Then copy the right side. We have secant theta, cosecant theta. Okay, next. The left side, this can be what? Actually, if you would like to cancel already, since we do have, well, there's something common on the denominator, so you can already cancel. But if you want to write this in terms of multiplication, because this is already in division and then reciprocal of denominator, you may do so. So if you would like to do it, so we have the numerator 1 over cosine squared of theta. The division will become multiplication. Then the denominator, so write the reciprocal. So we have cosine of theta over sine of theta equals to the right side. Then cancel. What's common? So we have here cosine and then denominator, we have the here squared. Okay, next. So let us just write the next step. So canceling, we have 1 over cosine of theta times 1 over sine theta equals to secant theta cosecant theta. Then applying again the identity. So 1 over cosine of theta is secant theta times 1 over sine theta, reciprocal is cosecant theta. So right side, you just copy. And then secant theta times cosecant theta. So it is equal to secant theta cosecant theta. So we're able to show that they are equal. Okay, next. So going back to the PowerPoint, so we have another example here. Okay. So on the next example, so I'll just write it on the black screen. So the example is secant squared theta minus 1 over secant squared theta equals to sine squared theta. Again, what you need to simplify is the complicated. So it will be easier for you. Rather than more making the complicated or making the simple complicated. But then, well, whatever is your solution or in which way or solution you are comfortable or you find it easier to do, it is up to you. So the left side is, well, seems complicated. So the numerator, if you would notice, so we have here the secant squared, we have 1. So this is somehow familiar. Okay, remember the 1 plus tangent squared theta equals to secant squared theta. Okay, so for us to come up with the secant squared theta minus 1, so it means that we're gonna leave the tangent squared on the left side, and then we have secant squared on the right side, and then 1 can be moved to the right side. It will become minus 1. Okay, so it means that the secant squared theta minus 1 can be written as tangent theta. So let us write this as tangent squared theta. So can be written as tangent squared theta over secant squared theta. So right side is sine squared theta. So this time, you can already write this in terms of sine and cosine. So in terms of sine and cosine, this one, so we can write this. So since we know that in quotient, tangent is equal to sine theta over cosine theta. But then this time we do have the power. So you just put the exponent also the power. So we have here sine squared theta over cosine squared theta. And then denominator, the secant squared theta, this is equivalent to 1 over, that is 1 over cosine theta. And since we do have here 2, so we're just going to put the power of 2. So we have denominator of 1 over cosine squared theta equals to sine squared theta. Again, as what you can see, so we have fraction on the numerator, fraction on the denominator. And both have the same denominators. So we can actually easily cancel this. Or if you want, okay, so I will clear the screen. So if you want, you can rewrite it. So sine squared theta over cosine squared theta all over or over 1 over cosine squared theta equals to sine squared theta. So since this is division, so we can make it multiplication, copy the numerator, sine squared theta over cosine squared theta. Denominator, so since division becomes multiplication, so we have to write the reciprocal of the denominator. So it will become cosine squared theta over 1. Again, you have to review your algebra. Okay? So now we can already cancel. So we have sine squared theta over 1 is sine squared theta equals to the right side. That's it. Okay, let us go back to the PowerPoint. So on number 3, we're able to show that left is equal to the right. So there are two solutions that I showed to you. But then if you have other solutions, so you can. Okay, on the last example, so that is 2 secant squared theta equals to 1 over 1 minus sine theta plus 1 over 1 plus sine theta. So rewriting, I'll just rewrite 2 secant squared theta equals to 1 over 1 minus sine theta plus 1 over 1 plus sine theta. Okay. So here, what is complicated is of course the right side. So you copy the left side. Then you can apply on the right side the LCD again. Apply LCD. So the least common denominator of this, so you can just multiply 1 minus sine theta times 1 plus sine theta. So multiplying this is equivalent to what? If you would like to have the product already, you may. But then if not, so let us just write it this way. But if you want to write the product, you can already do it. Okay. So 1 minus sine theta times 1 plus sine theta times 1 divided by the denominator. So we have here 1 plus sine theta. Plus, okay, on the next term, so LCD times the numerator 1 divided by 1 plus sine theta, which is the denominator of the said term. So we have 1 minus sine theta. Okay. So we can already try to simplify the numerator of the right side. So we have 1 plus 1. We have here 2. Sine theta minus sine theta. So that is what? We can actually cancel it, isn't it? Then on the denominator, so if you would like to multiply this already, so this is equivalent to 1 minus sine squared theta. That's it. And then, so just copy the left side. So we have 2 over. So the denominator of the right, this is somehow familiar. We have 1 and the sine squared. So in the Pythagorean, remember, we have sine squared theta plus cosine squared theta equals to 1. So we need to come up with the 1 minus sine squared theta. So that is by what? Writing the cosine squared theta, so on the left side. And then we have 1 on the right. And then sine squared can be written on the right side. So it will become minus. So 1 minus sine squared theta. So it means that it is equivalent to cosine squared theta. Okay? Next. So 2 secant squared theta equals to 2 over cosine squared theta. So 2 secant squared theta equals to, actually this one, it can be written as 2 times 1 over cosine squared of theta. So 2 secant squared theta equals to 2. So 1 over cosine squared theta, this is equivalent to secant squared theta. And left and right are equal. Okay, let us go back to the PowerPoint. So also in the handout, so we have the double and half angle identities. So you just take a look at this formulas. Okay, just for you to be familiarized with it. Although you already know this in your trigonometric class years ago. Okay. And we also have the sum and difference formula. By the way, in your PowerPoint, in the LMS, so I think there's a correction there. In number 2, so in number 2 of the sum and difference, so here, just to correct it, it is sine alpha, sine beta. Okay, after the plus, after the minus plus. Okay, so this one is correct. Then we have the product to sum formulas. So these are the formulas. Actually, you can try to prove this formulas and identities by substituting values to the angles. Okay, so if we do have just one angle on the identity or formula, so you make use of one value for that. If we do have two angles, so just like the alpha and the beta, so you can substitute angles, two angles, whether in degree. Okay, another one, it can be in region. But then if you have one, I think if you have one angle in degree, so just, well, just to be uniform, you can use another angle in degree also for the other one. Okay. Or if you want, region. Then we have the sum to product formulas. Okay. We also have here the cofunctions. So you just familiarize yourselves with this. Again, improving, you can do you can do the solutions we did a while ago with our topics. Okay. And that's it. Okay, so I hope that you learned about the trigonometric basic identities and formulas. Okay, thank you.